So two things I want to show you. One is how to deal with RPMs, and then the second thing I would like to talk about is the F word. And some physics teachers don't talk about the F word at all. Some say never use the F word in class, right? You can use it on your own, but I think there's a time and a place for the F word, okay? The first thing, though, I'd like to do is just teach you how to deal with RPMs. So let's just make a problem here. Let's suppose we have 7,200 RPMs, okay? And let's suppose that we're going 7,200 times every minute, and our radius is 0.05 meters, right? And this could be calm. Just be calm, okay? It's uncontrolled laughter. Okay, so I need to teach, so can you go out, or I don't know. Okay, so concept zero is at 7,200 RPMs. What this stands for is revolutions per minute, right? And so if they give you that, if they give you revs per minute, right, the simplest thing, and I think I'll show you the simplest thing, right, is that you can just simply find the period. The period is 60 seconds that are a minute divided by the 7,200 revolutions that you divided it into. Okay? So anyway, if you do that, if you divide that out, you get a period of 60 divided by 7,200. The period is actually really, really small. We knew this, right? Right? And if you look at the units, the per minute actually goes the way of the bison, and you end up with seconds per revolution, which is what the period is, right? And now you can just use this formula right here. You can go 4 pi squared times, and then the radius is, let's say, 0.05 meters, right? And then we're dividing that by 0.0083, repeating squared. Certainly don't round that. You don't want to round something that you square. So I'm going to go 4 times pi squared times 0.05 divided by the answer that I just got squared. And I get an enormous number because, of course, this is a really tight circle and it's going around really fast, right? And not all those figures are significant, yeah, right? Now, this is actually 7,200 RPM is what the speed that disk drives spin at, right? I don't know if that's the new one or the old one, right? And 5 centimeters is about the radius of those big metal disks in the disk drive, right? Or little metal disks, right? So obviously this is a tremendous amount of G-force. That's almost 3,000 Gs. So that's why they're made of metal, right? Concept one. And then concept two is that they have these devices called centrifuges. And the goal of a centrifuge is to basically do whatever gravity does, but do it faster. Right? So for example, in chemistry class, if you make a precipitate, like maybe they're doing that across the hall, right? A precipitate is just this cloudy stuff in the liquid. If you put it in a test tube rack overnight, it settles out and then you can decant the liquid and mass everything, okay? But if you don't want to wait overnight, you can put it in a centrifuge, and you always have to put 2 in, you know, so they oppose each other, right? And then spin it up, and at 3,000 Gs, right? If you could get a centrifuge to do this, in 3,000 Gs, it'll settle just like that, just boom, right? In like 10 seconds, you can take that out, and it's just like you let it sit overnight. So that's a cool thing. Isn't that a cool thing? Yeah. Yes. Okay. Now, let's talk about the F word, because we want to have enough time to talk about the F word. Okay? But this is the way I recommend you do that. Okay? Is just find the period and then just use this. Okay? Let's talk a little bit about the F word. So let me just tell you a story about when I use the F word. I was driving my car, and on the dashboard of my car was my brand new Glacier glasses. They were resting on the right side of the dashboard. I was driving my Rabbit, and I was going on to it was actually an on-ramp to a freeway, okay? And my glasses were on the right side of the car. There they were, right? And as I started going around the corner, okay, well, they were about there, they started to move. It was a weird thing. They were sitting still. The car is getting longer, apparently, right? Okay. As the car moved, it was here, it was here. At some point, my sunglasses, they got up and they moved. They were sitting still in the car, and suddenly they moved. And they started moving faster and faster. And they skittered across that flat area that rabbits have. Even the new ones did. I went to an auto show, and you sat down in the rabbit. It was like rounded area, flat area, same thing. I felt like I was at home, right? Then it went, and it hit that little thing that the speedometer, the instrument cluster, and it went, and it took some air, and the window was open. Had the window been shut, I might have still used the F word, only just maybe not, so loudly, right? But with the window open, my sunglasses actually went out the window. Yeah, there they were. I could see them. They were no longer in my car, right? Okay. And I used the F word. I said, and this might shock you, okay? I said centrifugal force flung the glasses from my car. Yes? That is the word that we have not said all period. We have said centripetal acceleration because that's what it really is doing, right? Is that objects going in a circle are actually accelerating toward the center, yes? I hope you're convinced of this, right? Why is it that we say centrifugal means center flinging, right? Why do we say that? Well, that's our experience, isn't it? If we're in that car and we're going around a corner, doesn't everything tend to go to the outside of the curve? Now, of course, what's going on? What are the objects really doing? What did my sunglasses really do? More or less, they went in a straight line, right? Objects are trying to go in a straight line. Centrifugal force is that feeling that you have when you're in a rotating frame of reference that everything's being flung to the outside. Yeah? Okay? But really, the sunglasses just went in a straight line, and that is the nature of all objects, right? Now, to be sure, as a child, I did not understand this. Okay, so, another random story from my childhood. I decided to ride my bike on a freshly tarred asphalt road. On the hot sun, what happens? You get tar on your back. The tar gets on your back because the tire kicks it up and it flies off the wheel and hits your back. So my mom said, don't drive on that road. Did I listen to her? No, I was smarter than my mom. So what I did was here's the wheel of the bicycle. Here is child butt and head, right? The wheel is somewhat behind you as you sit on the bicycle, yes, isn't it? I knew that the stuff that was flying off and hitting my back was flying off here and here. Is that correct? Is that how it flies off the wheel? Well, if centrifugal force is real, then yes, it does, right? But we know that things actually fly off tangentially, correct? Yeah. Yes, we know that, right? Because we're so smart. So what I did was to protect myself, I took a little piece of cardboard and put it right there. I taped it to my bicycle. It was one of those bicycles with a banana seat. Yeah? The cool ones. I taped it right there. No way that this tar could hit me, right? Because the stuff flying off here would miss me, right? It would fly straight off and maybe miss my head, right? A little farther back, right? This stuff would definitely be blocked. So I rode my bike on the tar street. What happened? Yeah, it was amazing. It was like hitting me there and hitting me there and hitting me there because, of course, it flies off tangentially, yes? Yes, I didn't understand. I thought the F word was real, right? So it's not really real, right? Patrick Kubishek sent me this. Anybody remember this child? The F word. He sent me this cartoon. How do you like my centrifuge, Mr. Bond? When I throw the lever, you will feel centrifugal force crush every bone in your body. You mean centripetal force? There's no such thing as centrifugal force. A laughable claim, Mr. Bond, perpetuated by overzealous teachers of science. Simply construct Newton's laws in a rotating system and you will see a centrifugal force term appear as plain as day. Come now, do you really expect me to do coordinate substitution in my head while strapped to a centrifuge? No, Mr. Bond. I expect you to die. I don't know. Yes? So basically, when you're in the rotating frame of reference, centrifugal force feels like it's real, okay, but it's just really just the tendency of objects to go in a straight line. But you can use it. You can solve problems with it.